All right, let's dive into something that every single programmer deals with, errors. We're going to talk about how to take our Python code from being super fragile, the kind that shatters at the first sign of trouble, into something that's totally robust and can handle the unexpected with grace and control. I mean, we've all been there, right? You've been coding for hours, you finally hit run, you're kind of holding your breath, hoping everything works, and then something goes wrong. And sometimes it's a line of code that looks so innocent. Look at this. Result equals 10 divided by 0. We're just doing some simple math. What could possibly go wrong? Well, as you know, in programming, sometimes the simplest looking lines are hiding a tiny little time bomb.
And bam, just like that, your program grinds to a halt. It crashes completely and spits out this big, scary error message. This one is a zero division error, and it just stops everything cold. The normal flow of your program is dead. But what if there was a way to see this coming? A way to catch it before it blows everything up?
Well, there is, and it's called the try/except block. You should really think of this as your code's safety net. It's the built-in tool Python gives us to actually anticipate and manage these kinds of program-stopping meltdowns. So that thing that crashed our program, that has a name. It's called an exception. It's basically an error that pops up while the program is actually running. And the key word here is handled. See, if we don't handle it, the program dies. But if we do handle it, well, then we're in control. And this really shows the difference, right? On the left, you've got that uncontrolled crash, the big explosion we just saw. But look over on the right. By wrapping that same exact code in a try/except block, we handle the error. We stop the crash, and instead, we can do something else, like print a nice friendly message. The program keeps going. Okay, but the control doesn't even stop there. The basic try/except is awesome, but we can get even more specific, even more powerful, by adding two more parts, else and finally. So here's how the whole thing flows. First, Python is going to try to run that risky piece of code. If something goes wrong, it immediately jumps down to the except block. But what if nothing goes wrong? What if it works perfectly? Then it skips except and runs the else block instead. And then no matter what, whether it worked or it failed, it will always run the finally block at the very end. Yeah, so the thing to remember about else is that it's your success path. It's the code that only runs if the try block made it through without any problems at all. This is great because it keeps your everything went right logic totally separate from your error checking code. It's just cleaner. And finally is your ultimate cleanup crew. Seriously, did you open a file? Did you make a connection to a database? The finally block is the guaranteed place to close those things. This is so important for apps that need to run all the time because it stops resource leaks that can, slowly kill your entire system. All right, so we've got the basics down. Let's level up a bit and look at some more advanced ways to handle different kinds of errors. So what happens if your code can fail in a bunch of different ways? Well, you can handle each one differently. You can have one except block for a value error and another one for a zero division error. Or if you want to treat them the same, you can just group them together like you see here. It gives you super precise control over how you respond to different problems. Sometimes just knowing an error happened isn't enough. You really want to know why. So you can actually capture the exception object itself using as e. This little e variable now holds all the details about what went wrong. It's perfect for logging the error or showing a really helpful message back to your user. And get this, you don't have to wait for Python to find an error. You can actually make one happen yourself. You do this with the raise keyword. This is awesome for when something isn't technically a Python error, but it breaks one of your rules. Like say if a user tries to enter a negative number for their age, you can just raise a value error and say, nope, that's not allowed. Okay, we've covered a lot of ground here, so let's boil it all down to a few simple, really powerful best practices. Think of these as the rules of the road for writing solid exception handling. All right, here are the big ones. First, keep your try blocks small. Only put the 1 or 2 lines in there that might actually fail. Second, be specific. Don't just catch a generic exception because that can hide bugs you didn't expect. Catch the specific error you're looking for. Third, use that else block to keep your success code clean and separate. Fourth, and this is a big one, always use finally for cleanup. And last but not least, log your exceptions. It'll make debugging so much easier later on. Okay, theory is one thing, but let's see how all of this actually comes together in a real-world example to build a program that's truly resilient. So let's imagine our program needs to open and read a file that a user gives us. I mean, what could go wrong? A lot, actually. Maybe the file doesn't even exist. Or maybe it does, but we don't have permission to read it. Let's build a safety net to handle both of those cases.
Okay, here's how we'd build it. First, in our try block, we attempt to open the file. Now, if the file isn't there, we'll jump to the accept file not found error block and handle that. If the file is locked and we can't access it, we'll hit the accept permission error block instead. But if everything goes perfectly, we'll run the else block to let the user know it was successful. And you can see, no matter which path we take, we always end up in the finally block to wrap things up. This makes our program super robust. It just won't crash.
And just to wrap it all up, here's a quick little cheat sheet for you. Try is where you test your risky code. Accept is where you handle the problem. Else is your success code. Finally is for cleanup no matter what. And raise is for when you want to create your own error. Simple as that. So think about where we started. We went from a program that would just crash at the slightest problem to one that can gracefully handle all sorts of unexpected issues. The big takeaway here is that errors aren't just things to be afraid of. They're events that we can and should manage. So the next time you're writing code, just ask yourself this. You know the unexpected is going to happen. How are you going to prepare your code for it?